Hey, I'm Mr. Williamson, and this video is about scientific method. Let's get started. First of all, why do we use it? Because it's basically a system that we can use to answer questions and solve problems. The thing about it is we use it all the time. We use it when you're working on a mechanical things or trying to solve a problem. When you play video games, you use it all the time. And today we're going to use it to bake. All right. So what are the steps? The first step, there are 7 of them. First step, recognize the problem. Second is collect data and form a hypothesis, test the hypothesis, observe and record the results, draw a conclusion, and report the results. There is some dispute over depending on what you read, but that's the 7 steps in my class. All right, so step 1, recognize the problem. And this is where there's usually a debate. There's a lot, I think even your textbook says the first thing you need to do is collect data. On what? I've always had an issue with that. I assume that we're looking at something and we need to solve a problem. So the first thing you have to do is recognize the problem. Ask a question. Like, how do wolves communicate? What makes leaves turn yellow? Why is water clear and watermelon red? Why does toast always fall butter side down? And the question we're going to look at today is, how can I make a better cookie? All right. Those are questions. I haven't done any research. Unless you count research, me eating the cookie and going, I think I could do better than this. But that's the first step, recognize the problem. Second step, observe. All right, so now I'm taking a look at using whatever I have, and I'm going to get to more of that, but using my senses, the first thing I'm going to do is I'll probably look at a recipe, and I'm going to look and say, well, what's out there right now? What can I use? I'm on the internet because, oh my God, there's so much available on the internet, and you know that. And then I'm going to look at cookies I've had. Like down the bottom I have here, I have these are oatmeal cookies, and I know I don't really like those. And I have tried the chocolate chip cookies with M&Ms, and yeah, I'm not a fan. And these over here, I don't know if you probably can't see them, are chocolate chip cookies with nuts, like walnuts. And to me, I don't get that at all, honestly. It wouldn't be a chocolate chip cookie if it had nuts. It's a chocolate chip and nut cookie, and we're not calling it that. So I know, after collecting some research, that I like chocolate chip cookies. That's what I'm looking for. All right, we're going to use, as we're collecting data, all your senses. So if you're a scientist and we're not just looking at cookies, maybe you are looking at how an insect builds a nest, and why does it pick the location it picks, or maybe the song of a bird. Does it have any meaning, and things like that. So you can use all your senses. I'm not sure about taste in the wild, but if I'm making chocolate cookies, I'm looking at taste. All right. I'm also going to probably organize some of that data, like birdsong. You definitely they categorize it into the different types of birdsong and then the reactions, and I could look at the data of where an insect lays its eggs. I guess insects don't really build nests, but where they lay their eggs, and I could classify it as dry or wet or something. Or in this case, we're going to be making cookies, or I'm going to want to make cookies, and I might be classifying like what are the ingredients, how much of the ingredients are there, and then different ideas as I go through the research, looking at the different recipes and things. What do they have and what do they don't have? So first thing, recognize problem. Second, I'm going to collect data on that problem before I come up with any thoughts. Which brings us to step 3, form a hypothesis. Hypothesis is a testable statement. It's something that we can do and test with observable data. In other words, it's an educated guess based on the research and observations that we've made in the collecting data stage. All right. So my educated guess is I'm going to look at the cookies, and I have an idea of how I might want to fix them or make them better. I could say, okay, on the insects laying eggs, I would look for particular dry spots and or something like that. But it's based on the research. It's not just a wild random guess. It's an educated guess based on research. All right. You're basically predicting the future. You're predicting what is going to happen in advance. It's an if-then statement. If the conditions are dry, then this type of insect will lay its eggs there. if I add more butter to my cookies, then they will taste better. And that's my hypothesis. If I add more what the heck? If I add more butter to the cookies, then I'll have better tasting chocolate chip cookies. So step 4 is test that hypothesis. All right. This is the part, by the way, that a lot of students seem to have issues with. Is this next? There's a lot of parts to this. We're going to do an experiment. All right. I'm going to test my hypothesis under a controlled condition. It's a controlled experiment. So I've got a batter over here with a lot of butter, and my hope is that I come up with some better cookies. That's what I'm looking for. All right. It's called a controlled experiment. A controlled experiment is not an experiment that you control. A controlled experiment, it consists of 2 groups, a control group and an experimental group. All right. You do not control it. You are not determining the outcome of the experiment. You're determining the conditions of the experiment. That's what makes it a controlled experiment. It's not, hey, I can tell you how this is going to come out. You don't know how it's going to come out. What you're doing is setting up the situation to determine not how it comes out, but how you'll know the results. There's 2, like I said, 2 groups. The control group is the group that we're going to compare it to. In my case, or this case, it would be the cookies, the original cookies, the cookies that I've always had and I've always liked. They're good, but I think I can make them better. That's my control group. I'm not going to change them at all. I'm going to make the same recipe the same way, bake them at the same temperature and all that. All right, so everything in the control group stays the same. The experimental group is where I'm going to have the test the hypothesis. So this is where I'm going to put the batter with more butter. All right, I'm going to add more butter to this group. All right, and that's my independent variable. And there's 2 variables in every experiment, the independent variable and the dependent variable. So, but to go back, I have the control group, which I don't do anything to. All right, that's my, what am I going to compare it to? I have to have something to compare the result to. I know how this is going to taste. So I'm going to make a batch of these, and I'm going to have some cookies that I like, but I'm going to also make a batch with the butter and see. And the idea is to see which one I like more. All right. Now, what is an independent variable? That's the thing I control. All right. I control the butter. That's the thing that's different. Everything else in the recipe is going to be the same. We're going to do it the same bake temperature, time. We're going to put the same amount of flour in. We're going to put the same amount of chocolate chips in. We're going to do everything exactly the same amount of sugar, just the butter. The butter will be different. That is my independent variable. All right. The dependent variable is the result, and that's the thing that confuses. The independent variable is what's different between the 2 groups. The dependent variable is the outcome. How do the cookies taste? Do they taste better? Do they taste worse? So the independent variable is the change. The dependent variable is the result. One way to think about this is I control the independent variable. I control the independent variable. Okay? One more time. I, starts with I, control the independent variable. That's the thing that we're changing. The dependent, and this should not say defendant, that's bad of me. The dependent variable depends on the outcome. The dependent variable depends on the outcome. Depends how it's the dependent variable. Well, it depends on what happens. I don't know what's going to happen. Depends. What's the independent variable? What's the thing I control? How much butter do we get? All right. Step 5. After I've done the experiment, I'm going to observe and record the data. All right, I'm going to quantify it. So how fast does the yeast cell? How many insects do I find? Laying their eggs in a dry area, or in a cookie taste thing? That's not really quantifiable because you can't say, because I might like the cookies more than you, but I could say, well, on a scale of 1 to 4, how do I like these cookies compared to the other cookies? Are they better? I'm trying to assign it to a number because numbers are easy to work with. All right. So maybe I'm also giving the samples to other people and saying, hey, which cookie do you like better? And they say, oh, it's this one or that one. It's this first one or the second one. And that'll give me quantifiable data, numbers. I'm going to organize that data just like we did before, put it in logical, readable order, group things together, You do that with all data. So we're trying to just organize things so we can get a picture of what we're looking at. We're looking for the result of the experiment. How did it come together? Step 6, form a conclusion. Based on that experiment, the data we got from it, what is our conclusion about the hypothesis? Did adding the butter make the cookie better? All right. So we analyze the data, drawing a conclusion about the facts. The bottom line of this part is, was the hypothesis correct? Was my hypothesis, if I add more butter, then the cookies will taste better? Was it correct? That's what we're looking at. All right. Or my hypothesis that insects lay the eggs more in a dry area of whatever. And then I go out and I look for the dry areas, and do I find those insect eggs? Was my hypothesis correct? That's the bottom line of forming a conclusion. All right. If the hypothesis is correct, I would go back and test it. For instance, I would make another batch of cookies, and do they still taste good? Maybe I got lucky on the first one, so I'm going to try it again. In other words, I'm kind of testing, is the experiment valid? I don't just do it once. I test it. If it's wrong, then probably my hypothesis is wrong. Maybe I need to restate it. Maybe I need to go back and take a look and test something else. Maybe I add more sugar. Maybe I add more chocolate chips. And you can never add too many chocolate chips. But it's a failure is not, in science, a failure is not failure. It's eliminating a possibility. It's not a mistake. It's, okay, that didn't work, so what works? One of the things to think about, another way to think about this, and I'm kind of taking a little side trip here. You do this all the time if you play video games. You have a problem. You've got to solve whatever the issue is, the obstacle on the screen, or in the game, and you collect data. What do you already know about the game? You know how to control your character or your whatever, and you know what the possibilities are, and you know what the desired outcome is. You form a hypothesis. Based on all that, what can you do to get past this obstacle? Whether it's a first-person shooter game or a racing game or whatever, or a puzzle game, you are forming a hypothesis. If I do this, then this will happen. All right, and then you go out and test it. You do the experiment. The independent variable is the thing you did differently than the first time you tried it and you died. All right, oh, I died. Well, that didn't work. So why form a hypothesis? If I do this instead, I will survive and I will get past the obstacle. And then you form a conclusion. If you get past it, success. If you didn't, you try something different. It's not a failure. It's just you're not succeeding at that time. Step 7, we're going to report the results. All right, and that happens in all the scientific community. We report the results. I have to report it to the scientific community because I have to be verified. It isn't just say, oh, I did this, I made the world's best cookie. I have to show people. So I'm going to share my cookie with people. I'm going to share this is an amazing cookie. And hopefully everybody's like, yeah, these are amazing cookies. This is great. But then I need other people to be able to duplicate my experiment. So I give them the recipe too, in detail. Turn the oven on this, maybe even affecting the humidity of the kitchen. I don't know. But I'm going to share my recipe. And they should be able to produce the same great cookie that I did. You do this in video games, like I said. You get past the obstacle and you're talking with your friends, and you're like, well, how did you get past this thing? And you tell them, hey, I did this. And they go out and they try the same thing. If they can do the same thing and get by, then they're good. If they can't, then maybe your experiment was wrong. All right? So I report the results. In the scientific community, they do it in journals. They'll write an article, a very detailed article, like how they did it, what the results were, why they did it, all their research. And then other scientists go out and test it. And they say, well, this doesn't work because blah, blah, blah. Or this is, this shows that this, and they can build on it. But you always report your results. So here again, 7 steps to scientific method. Observe and collect data. Actually, like I said, that's what your textbook collects. I would much rather see these 2 right here switch. Recognize the problem. You have a problem. You have a question. Ask it. Collect data. Based on that data, form a hypothesis, an educated guess. Test the hypothesis. You're going to do a controlled experiment. You're going to have 2 groups. A control group where you don't change anything, and an experimental group where you do make one change. All right? Um, and going to that real quick, why only make one change in an experiment? Well, if you're working on, let's say I'm working on my motorcycle and it doesn't run, and I change all these things, like three things. I change the gas pump, and I change the air filter, and I changed the fuel line, and it now works. So what was the problem? I don't know. I don't know what the problem is. But if I only change one thing and it doesn't work, then I know that wasn't it. And I change the next thing and it doesn't work, and I know that wasn't it. When I change the next thing and now it works, now I've figured out what the problem was. So testing an hypothesis, I'm changing one thing: control group, experimental group, and the difference between the two is the independent variable. That one thing that I'm testing, the butter or whatever. All right. And then I'm looking at the dependent variable. What was the result? How did the experiment come out? All right. I observe, record the results. I draw a conclusion. It was successful. It wasn't. My hypothesis was correct. My hypothesis was incorrect. And then I report the results in the scientific community, in journals, in real life, probably to your friends, or maybe just to you. Hey, I fixed it. Now I know how to do it correct. The things you should know. What is a controlled experiment? A controlled experiment is an experiment that has two groups, an experimental group and a control group. All right, it's not an experiment that you control the outcome, you control the conditions. The control group is the group that you do nothing to. It's the group that stays the same. The experimental group is the one that you're changing, one thing. And then the control group is what you compare the experimental group to. So I'm comparing the experimental group to the control group to see the result. The independent variable is the thing that I'm changing between the two groups, and the dependent variable is the outcome of the experiment. So if you have any questions, make sure you put them at the last question of the Edpuzzle, or ask them in class when we go over this. Hopefully you understand this. We're going to be doing a few activities in class to help understand it a little bit more. But bottom line, this is something you really do every day. You are doing the scientific process. You are forming a hypothesis, you're testing the hypothesis, and you form a conclusion. Maybe you don't do a lot of research, but in a way you do. Experience sometimes. Scientific method, important in real life, more important in science. Hope you understand. If you have any questions, ask.